We all learned it in school, right? Earth goes around the sun. Seems like one of the most basic facts of science, the absolute bedrock of physics.
It certainly feels that way, but the sources we're looking at today, they really push back on that. They bring up some historical claims and even some interpretations of modern physics that suggest, well, a very different picture.
Yeah, it's pretty mind-bending stuff. So today we're doing a deep dive into this really fascinating, maybe even contentious part of physics history.
Exactly. Our goal here is to unpack what these sources are saying. They propose this idea of a stationary Earth. They talk about this mysterious substance called the ether, and they take a critical look at Einstein's theories of relativity.
So we're going to trace the path of a few really key experiments, according to these sources, and the pretty fierce debates that surrounded them.
It really makes you think about fundamental assumptions, doesn't it?
It does. The sources ask, what if a lot of what we think we know about light, about our planet's movement, what if it's built on a shaky foundation?
Yeah.
It's definitely a trip through some apparently contradictory results and big scientific arguments.
Okay, so let's set the scene. Late 1800s, the idea that the Earth orbits the sun, the Copernican system that was, pretty much accepted science.
Right.
But there was this nagging detail, this thing called the ether. See, the physics back then, like Maxwell's incredibly important equations for electricity and magnetism, they kind of assumed space wasn't empty.
Assumed. So they thought there was stuff out there.
Yeah, exactly. This ether. It was thought to be this invisible, stationary substance that filled all of space. And it was the medium, the stuff that light waves and other electromagnetic waves needed to travel through. Like waves need water.
Okay, so it provided a kind of fixed background for everything.
Precisely. A universal frame of reference. But they needed to prove it was there and, crucially, measure Earth's movement through it.
Which brings us to the Michelson-Morley experiment in 1887.
The big one.
Yeah. So their goal was to measure Earth zipping through this ether, right? How do they plan to do that?
Well, they used this clever device called an interferometer. The idea was, think of swimming in a river. If you swim upstream against the current, it's slower than swimming across the current, right?
Makes sense.
They thought the same would happen with light traveling through this supposed ether wind caused by Earth's orbit. A beam of light going into the ether wind should be slightly slower than a beam going across it.
So they expected to measure a difference in light speed depending on the direction.
Exactly. They were looking for a difference corresponding to Earth's orbital speed, which is about 30 kilometers per second. A tiny difference, but their instrument was sensitive enough, they thought.
And what happened?
Well, this is where it gets interesting. The result was basically nothing. They measured a velocity maybe somewhere between 1 and 10 kilometers per second, but that was considered tiny, negligible, a null result, they call it.
A null result, so no significant difference.
Pretty much. And according to the sources we're looking at, this was huge. They state flatly that the experiment failed to detect the Earth moving in or against the ether.
And the implication for them.
The sources claim this meant the Earth was motionless. They say this result just shook the scientific world and had, quote, devastating implications for the whole Earth orbits sun model.
Wow. Okay, so hold on. Mainstream physics today doesn't say the Earth is motionless because of this experiment.
Oh, absolutely not. Mainstream physics has a completely different interpretation involving relativity, which we'll definitely get to. But these sources, they really hammer this point. The experiment didn't find the expected motion.
So according to these sources, science suddenly had this massive dilemma.
Right. Either check out the ether theory, which was fundamental to so much physics at the time.
Or admit the Earth isn't moving around the sun.
Exactly. A tough spot. And according to our sources, this led to what they call a pretty desperate attempt to save the situation. This idea called the Fitzgerald-Lorentz contraction. It was rushed out pretty quickly. The theory basically said that the measuring instrument itself, the interferometer arm, physically shortened in the direction it was moving through the ether.
Shortened. The seal arm just got shorter.
That was the claim, just enough to perfectly cancel out the expected difference in light speed and explain the null result.
Okay, that sounds convenient.
Our sources are, let's say, deeply skeptical. They call it a ridiculous theory, stress there was no evidence whatsoever for this physical contraction happening. They label it physics of desperation.
Almost like making up a rule to fit the data.
That's certainly how these sources portray it. They even say it's more akin to a fairy tale for adults than it was science. And they point out maybe it should have been called an expansion anyway, depending on how you look at it.
So the situation is messy. The key experiment didn't show Earth's motion through the ether, and the explanation felt like, well, a fudge.
According to these sources, yes. And that's the backdrop against which Albert Einstein appears. Our sources position him as the person who came up with the solution, the one who essentially saved the heliocentric model.
With his theory of relativity.
Hmm.
Special relativity in 1905, then general relativity later.
Right. And what did Einstein do, according to these sources? He simply abolished the ether, just got rid of it.
What was his reasoning?
His radical idea was that the speed of light isn't relative to some ether, it's constant. Absolutely constant for every observer, no matter what speed the observer is traveling.
Okay, so if the speed of light is always the same for everyone, then you wouldn't expect the Michelson-Morley experiment to show any difference anyway.
Exactly. Our sources say this postulate explained away the null results. No need for an ether, no need for length contraction. The result makes sense if light speed is universally constant. Problem solved, model saved.
Our sources don't buy it.
Not entirely. They raise what they see as a fundamental flaw. Light travels in waves, right? We know that. And their argument is simple. A wave needs a medium through which to travel.
Like sound needs air or ripples need water.
Precisely. They use the analogy of trying to imagine a wave in water without the water. They argue it's absurd to talk about light waves propagating through absolutely nothing.
Is there anyone specific they quote on this?
Yes, they bring up Professor Herbert Dingle. He was initially a big supporter of relativity, even wrote textbooks on it, but he later became a major critic. Dingle apparently called the idea of light waves without a medium, without a standard for their speed, the grin without the Cheshire cat. Pure absurdity in his view.
So the sources essentially say Einstein just declared the ether gone by decree without proving it wasn't there.
That's the assertion, yes. That he removed the ether from existence by edict.
Okay, so if Einstein supposedly abolished the ether, but these sources insist it's necessary, did any experiments after Michelson-Morley seem to support the ether idea?
Now we get to the Sagnac experiment from 1913. This one is really central to their argument against relativity.
Sagnac? How did that one work?
It involved a rotating platform. A beam of light was split, sent in opposite directions around the edge of this rotating table, and then brought back together to create interference fringes.
Interference fringes. Those patterns you get when light waves overlap.
Exactly. Patterns of light and dark. Now, the crucial part, when the table was rotated even slowly, like 2 times a second, the interference fringes shifted.
They shifted. What does that mean?
A shift in the fringes means the 2 beams of light took slightly different times to complete their circuits around the rotating table. Something affected their travel time, or path length.
And how do our sources interpret this shift?
They make a very strong claim. Quote, "The very significant result of the Sagnac experiment was that it proved that the ether existed." And they follow up by saying this result demolishes relativity.
Whoa, okay. Demolishes relativity. What's the logic there?
Their reasoning goes like this. If relativity is right and there's no ether, the speed of light is constant relative to the detector on the table. So rotating the table shouldn't make any difference. The fringes should stay put.
They did shift.
Right. But, they argue, if there is a stationary ether that controls the speed of light, independent of the table's motion, then when the table rotates, one beam is traveling slightly with the rotation relative to the ether, and the other slightly against it.
So one beam effectively travels a slightly longer path through the ether, and the other a slightly shorter one in the same amount of time, or takes a different time.
Exactly. The travel times become different, causing the waves to recombine differently, which shifts the fringes. And Sagnac apparently calculated exactly how much the fringes should shift based on the rotation speed and the ether theory, and found that they shifted by precisely that amount.
That sounds pretty direct, if their interpretation is correct.
It's a cornerstone of their argument. And they add another point. They claim the Sagnac effect isn't just some lab curiosity.
Oh, where else is it used?
They state that the Sagnac effect is used by airlines for their compass directions. They're talking about ring laser gyroscopes used in navigation systems.
Laser gyroscopes.
Yeah.
Like in airplanes and missiles.
That's the implication. The sources argue these sophisticated optical compasses would not work at all if there wasn't an ether. They see it as practical, everyday proof that there is an ether and impeaches Einstein's claim that there is no ether.
So Sagnac is presented as positive proof for the ether. directly contradicting relativity's foundation.
That's the claim. And they argue Sagnac isn't alone. It fits into a pattern, along with Michelson-Morley, suggesting a stationary Earth.
What other experiments do they bring up?
Well, they go way back to James Bradley in 1729, whose observations on starlight aberration, they claim, prove the ether isn't dragged along by the Earth. Then there's the Michelson-Gale experiment in 1925.
Another Michelson one.
Yes, different setup, more sensitive, designed to detect the Earth's rotation relative to the ether. Our sources say it proved the ether passed over the Earth once every 24 hours. Though they concede it didn't strictly prove whether it was the ether moving or the Earth rotating.
Interesting nuance there. Any others?
They highlight an experiment by George Airy in 1871, sometimes called the Airy's failure. Apparently, Airy filled a telescope with water, expecting to need to change its tilt to see stars because light would slow down in the water.
And
He didn't need to change the tilt. According to our sources, this proved to Airy's dismay that the Earth isn't moving. Rather, it was the ether carrying the stars that was moving over the Earth, and that the Earth was stationary.
so they're citing a string of experiments.
Mm.
Michelson-Morley, Sagnac, Bradley, Michelson-Gale, Airy.
And a few others briefly mention Muscart on light polarization in 1872, Dudras on mutual inductance in 1889, Trout and Noble in 1903. All of which the sources claim are consistent with a stationary Earth.
Leading them to a pretty bold conclusion.
Extremely bold, they state. There is not a single experiment that proves that the Earth moves. The moving Earth is based entirely on a theory and is contradicted by all of the experimental evidence.
Wow. Okay, so if all this experimental evidence, according to them, points away from a moving Earth and against relativity, how do they characterize relativity itself?
Oh, they don't hold back. They describe it as riddled with contradictions and problems, call it a complete lie, and say it's based on convoluted and deceptive mathematical models.
Deceptive mathematics. That touches on a really interesting point about math versus physical reality.
It does, and they bring in Nikola Tesla here. They quote him warning that modern scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality.
A strong warning against prioritizing math over physical testing.
And this leads back to Professor Herbert Dingle, the relativity expert turned critic we mentioned earlier.
Right, the grin without the Cheshire Cat guy.
That's him. Our sources really focus on his story. They say that in 1959, after years of championing relativity, he found what he considered a fundamental paradox, a logical contradiction within special relativity itself, related to the infamous twin paradox.
A paradox. What did he do?
He apparently spent 13 years trying to get answers from the scientific community, including writing to Einstein himself, though Einstein died before resolving it to Dingle's satisfaction. Crucially, the sources claim he was effectively shut out, refused access to scientific journals to publish his critique.
Shut out. That sounds serious.
Very. Eventually, in 1972, he published a book called Science at the Crossroads. Our sources describe this book as presenting unimpeachable proof that the theory of relativity is invalid.
Unimpeachable proof. What was his core argument against the math?
His most damning quote, according to the sources, is this: "In the language of mathematics, we can tell lies as well as truths, and within the scope of mathematics itself, there is no possible way of telling one from the other." He called that the dirty secret behind the theory of relativity. The sources use a simple analogy Dingle apparently used. You can write mathematically that a half-empty glass equals a half-full glass. That's true, right?
Sure, they're the same thing.
But then Dingle said, multiply both sides by 2, you get empty glass equals full glass. Mathematically valid step, but the result is physically false. His point was that math alone can prove absurdities if not constantly checked against reality.
So he felt relativity had become unmoored from physical reality, lost in its own math.
That seems to be the crux of it. Dingle apparently argued that once the terrifying mathematical machinery of tensor calculus took over in general relativity, most physicists just gave up trying to understand the whole business.
Gaze up.
He claimed they surrendered the use of their intelligence and just passively accepted whatever apparent absurdities the mathematicians put before them.
That's a heavy charge against the physics community.
It is. And to bolster this idea of relativity as perhaps more invention than discovery, the sources quote Einstein's own biographer, Ronald Clark. Clark apparently reported Einstein admitting that his gift of fantasy has meant more to me than my talent for absorbing positive knowledge.
His gift of fantasy.
Based on that, the sources draw their own conclusion. The theory of relativity is not science, it is fantasy.
So, experimental evidence points to a stationary Earth. Relativity is mathematical fantasy. Where does that leave the scientific establishment that upholds relativity?
Well, this is where the sources get really provocative. They start talking about motivations beyond just science.
What kind of motivations?
They allege that the scientific establishment, or what they sometimes call the priesthood of science, didn't reject the stationary Earth idea based on evidence. Instead, they claim it was rejected because the moving Earth, the heliocentric model, had become the central faith of the godless scientific community.
Wow, okay, that's a strong accusation,
Hmm.
tying it to belief systems rather than data.
Extremely strong. And they claim there's been a virtual blackout on teaching these counter experiments like Sagnac. They give examples of physicists, even ones specializing in relativity, who supposedly had never even heard of the Sagnac experiment.
A deliberate suppression of evidence.
That's the implication. They compare the scientific community's adherence to relativity, despite what they present as contradictory evidence, to adherence in a religious cult.
A religious cult.
Yes. They even quote Dingle again, observing that science, which historically fought against dogma, had, in his view, become more dogmatic than theology itself when it came to relativity.
Are there other notable critics mentioned besides Dingle and Tesla?
They briefly list a few others. Charles Lane Poore, a professor at Columbia, who apparently said relativity strikes directly at our fundamental concepts and upsets common sense. Dr. Lewis Essen from the UK's National Physical Laboratory and a fellow of the Royal Society reportedly called it not truly a physical theory.
Essen. Wasn't he involved with atomic clocks?
Yes, a very respected experimentalist. And they even mention Lord Ernest Rutherford, the father of nuclear physics, supposedly dismissing relativity as simply nonsense in private conversations, though perhaps more off the cuff.
So, quite a few respected names, according to these sources, had serious doubts or outright rejected it.
That's the picture they paint, a collection of experimental results and critical voices challenging the mainstream.
Okay, so wrapping this up, we've explored sources that fundamentally challenge core scientific beliefs. They present experiments like Michelson-Morley and Sagnac not as proofs for relativity, but as evidence against it, evidence supporting a stationary Earth and the existence of an ether.
Exactly. And they argue that despite this evidence, the prevailing scientific narrative anchored by Einstein's relativity continues to dominate, potentially due to factors beyond pure empirical evidence.
It leaves you with a lot to think about. The sources really push back hard against accepted science.
They certainly do. And perhaps that leads to a final thought for you, the listener, to ponder. If these sources are correct, that highly respected scientists could, at one point, champion theories they later called fairy tales or fantasy, well, it makes you wonder, doesn't it?
Wonder what?
What other fundamental assumptions, perhaps even today, might we be accepting without rigorously checking them against all the experimental evidence ourselves? It's a question about how science works, how ideas become accepted, and the interplay between experiments, math, and, well, the beliefs of the scientific community.